Okay, so this video is going to cover 9.5 and it's going to cover graphing quadratics. So graphing quadratics. And a lot of the methods that you learn in this section will apply to any graphing, any kind of graph that you come up with. First of all, we call the graph a parabola. And that's just the U shape. Whoop. It goes this way, right, with the vertex right here, or it could go this way with the vertex here. And the vertex that I just used is the lowest or the highest point, depending on which direction it goes. It's like the turning point, right? So if it's this one, it's here. If it's this one, it's there. It's where it turns the other way. And of course, your graph, your X and Y axis would be somewhere on that. But these are the two options. This is obviously the lowest point, and this is the highest, or sometimes this is called the minimum and the maximum. Okay, so those words might be used. All right, so the general idea is that we look at the first, this is like the parent graph. And the parent graph is either y or f of x equals x squared. And this could be f of x, either way. So the parent graph is just, what does this generally look like? Okay, so for this one, if I put in points, if you did your xy chart here, and I pointed points like 0, well 0 squared is 0. If I put in 1, 1 squared is 1. If I put in 2, 2 squared is 4. Now put in some negatives so we can see both sides of the graph. Negative 1 squared is 1. So if I put in negative 1, I get 1. What if about negative 2 squared is going to be positive 4? So they kind of mirror each other. Negative or positive x's come out positive on the y for the parent graph. So we have 0, 0, and then we have what? The point 1, 1. 2, 4, 2, probably shouldn't have done that as 1, but that's all right. 3, 4, it's up here in my top of my graph. Negative 1, 1, and then negative 2, 4, negative 2, 4 would be up here. So our graph is going to look like this. And you could easily use technology for a lot of these graphs as well. Download an app or use a graphing calculator. Okay, so for this one, this is our parent graph, and everything we do to this is called a transformation, and it changes it around. So basically, we can look at different numbers, and they will move this thing around. So first of all, our vertex form looks like this. Plus k. And I would love to show on a calculator a couple of the basic things, but we'll just talk about it and I'll graph a couple for you. But basically we'll have a number in front of our squared section. Okay, we could add or subtract a number to the x in the squared section and square that, right? And we could add or subtract a number on the outside. Each of these three numbers does something different to this general shape. This number here is going to change the direction. If it's negative, it flips it upside down. Okay, so here's our general one. If it's negative a, it flips it upside down. If it is a higher number like 2, 3, 4, anything bigger than 1, even if it's negative, because the negative is just to do with upside down or right side up, it is going to make your graph skinnier or compress it. And then if this number is a fraction or a decimal less than 1, it is going to make it fatter or widen it. And so let's look at a couple of those things. Let's see. And then also HK is our vertex. So notice this is a minus in here. That's huge. So the vertex, this is usually called vertex form, but one of the books doesn't call it that. I don't know why. So vertex form is where you can see the vertex. It's always the opposite of this one. So it's going to be H and then this number here. So if this was a positive, this would have been a negative on the vertex. So let's look at my first example. Like let's say I have f of x or y equals, let's not do an a value yet. Let's do x minus 2 squared minus 4. Okay, so when we look at this, what have we done to our parent graph? Well, we've added in the -2 here and the -4. And so if we can see the vertex, we always want to write that down first. What that has done is that's moved it 2 here to the right, and then this one's moved it down 4. So the first thing I want to notice is the vertex. And the vertex is going to be +2 because it's a negative in there, and then -4. So whatever's here, opposite sign here is your vertex. So if you're asked for the vertex. And again, this number is going to move you right and left. This number will move you up, down. So let's look at what we've done. So the vertex is now at 2, -4. So here's 2, -4, but we don't really know any other numbers. So once you find the vertex, see we moved over 2, see that? And then this one moved you down 4. So the same idea as a vertex. So these transformations are just really coming up with a vertex for these two numbers. What did you do moving you this way, and what did you do moving this way? So if you just have an x squared and no number attached, you did not move this way, right or left. And then this number again moves you up or down. But if you don't have that number, you didn't move up or down. You stayed at the 0, 0. So here we are. I'm going to do a little chart. And I'm going to find numbers on both sides of this vertex so that I know the shape of the U. It is the general shape, so because I didn't put an A here, so it's going to be pretty easy to find. So let's look at maybe 3, because 3 will get on this side of our vertex. So 3 minus 2 is 1. 1 squared is 1. 1 minus 4 is -3. So at 3, we're at -3. Okay, so then let's put in 1 because it's one way this way. 1 minus 2 is -1. -1. I'm at the coffee shop and a bird just mashed into the window. -1 squared is 1. 1 minus 4 is -3. So at 1, we're also at -3. Oops, should be down here. I don't know why I put it up there. -3. 1, 2, 3, -3. Sorry. So 3, -3, 1, -3. So there's our general shape. So there we go. So all we did was take this general graph here, our parent graph, and we moved it over and down. That's it. Over 2, down 4. And that's the general idea. Okay, so let's look at a couple if we add in that A number. Okay, so if we add in the A number, we'd look maybe like, well, you can use a y or f of x. Let's try a -2, and then maybe x plus 1 squared. And I'm going to leave off the number, the number here, just to give us an example of one like that. So here we are. What can we tell about this if we have the -2 here? Well, we can tell that it is going to be upside down, and the 2 will make it fatter or skinnier. You have to think about that. It's going to make it grow faster, so it makes it skinnier if this number is above or below 1. Okay, so bigger than 1. All right, so let's look at the graph. What would be our vertex? Well, our vertex would be at the opposite sign, so it's good, -1, and we don't have anything here, so we'd use a 0. Okay, so -1, 0 is here. So there's our vertex, and then we need to come up with a couple more points to see that 2, that scale factor that makes it go up faster. So at x, let's put in 0 maybe, because we need something on this side and something on this side. So maybe we'll use 0 and -1. I mean -2. -1's here, so -2. Okay, so 0 plus 1 is 0. I mean, plus 1 is 1. 1 squared is 1. 1 times -2 is -2. So at 0, we're at -2. And at -2, -2 plus 1 is -1. -1 squared is 1. 1 times -2 again is -2. So at -2, we're also at -2. And so our graph looks like this. Okay, does that look skinnier? I didn't do a real good job of my U. It almost looks like a V. But does that look skinnier? A little bit. And as that number gets bigger, it'll get skinnier and skinnier. Okay, and we from our parent graph, right? This flipped us upside down. This moved us to the left one because it was the opposite. And we didn't go up and down because we didn't have a number on the other side. So it's kind of the general idea. So let's look at one more. So what if I have f of x equals negative 1/3? And then maybe I'll just do, oops, maybe I won't do the parentheses. You don't need the parentheses. What if it just said negative 1/3 x squared plus 1? We can, it doesn't look like it's in vertex form, but there's no x term, so it still is. You can see it as 0, 1 as the vertex. Okay, and then from here, let's see here what that 1/3 does. I did a negative again, so that's going to flip us upside down. And we know our vertex is at 0, 1. So we didn't move to the left or right, but we moved up 1. And then from here, let's do our little chart and come up with a couple other points from the left and right. Maybe let's use negative 1 and 1. So negative 1 squared is 1. 1, you have to times first, times negative 1/3 is negative 1/3. Ooh, I mean, it's not that big a deal. Negative 1/3 times 1 is negative. I was just thinking it's negative 1/3. Maybe we don't want to come up with a fraction, but I don't know if I care. So let me do that again. Negative 1 squared is 1. 1 times negative 1/3 is negative 1/3. Negative 1/3 plus 1 would be negative 1/3. It would be a positive 2/3. So if you needed to come up with that, that's fine, or you could look at the decimal. So 1 squared is 1. 1 times negative 1/3 again is negative 1/3 plus 1 is going to give us 2/3 as well. And you could get a common denominator and come up with that. So at negative 1, you're at 2/3. Ooh, 2/3. I don't know, looks about there. And at positive 1, you're at 2/3. So can you see that this one is clearly going to be a little bit fatter, right? So very different from the one we just did. The other one was skinnier. This one's fatter. And if you did it on a calculator all at the same time, you could do the parent graph and then do the fat ones and the skinny ones. Or this is a horizontal stretch. No, this is, yeah, I'm trying to make sure I said that word right. It's a stretch or compression. This one would be a stretch. And the skinnier graph would be a compression, squishing it in. But you can look at it this way too and think of it this way as your stretching compression. So those ones, that word gets a little bit confusing for some people because you can do one, you could call it different things. So a vertical or a horizontal compression is a vertical stretch. So like they are the opposite of or they do the same thing. So let's just look at a couple things and then let's see. So let's look at, what if I just have, oops, this is too high up. So what if I just have f of x equals negative 4/3 x minus 3 squared minus 1. Okay, you're going to be asked things like this. Does this graph from the parent graph move to the right or left? Well, it's a negative 3, right? And this one does right and left. So it's going to move to the right for the positive direction. And does it move up or down? You're going to be asked that. Well, yeah, it moves down 1 because that's a negative 1. And what is a negative 4/3? Well, the negative 4/3 is a little confusing because you think it's a fraction, but that fraction's bigger than 1, so it's going to make it get, it's a bigger number, so it's going to get skinnier, not fatter. And you could graph it to make sure you knew the difference between the skinny and the fat with that fraction, but that fraction's bigger than 1, so it's going to make your graph go skinnier. From here's your parent, skinnier. All right, so all of these are graphing with the graphs in vertex form. So there'll be another video on not vertex form.